Good morning. Let us take an interesting problem. Nearest prime to a given number. For example, if 25 is given, (26) is not prime, 27 is not prime, 28 is not prime, 29 is prime. Okay. Similarly, on the other side, 24 is not prime, 23 is prime. Fine. So how far 23 is? 23 is 2 units on left hand side. On left hand side. 29 is 1, 2, 3, 4 units on right hand side. Okay, so which is closer? 23 is obviously closer. That we need to find out. Suppose this is I. This is I. And this is J. Logic is if I less than J, (25) minus I is closer. If I greater than J, then 25 plus J is closer. If I equal to J, both. Okay. So hope you understand it. So we start with I equal to 1 on below side, J equal to 1 on above side, and continue till we get a prime. Okay. There are special cases. When n equal to 1, nearest is 2. When n equal to 2, nearest is 3 only. Okay, there are special cases. Is this clear? N equal to 1, you have only 2. N equal to 2, no, nothing below. Because less than 2 is 1, less than 1 is 0. So these two are special cases. They need to be dealt separately. Okay, so let us start writing the code. Let us go to online C# editor. The code is simple. You need not go to Visual Studio project for it, which takes a lot of time. Right. So we have a class and we have a method. Here we call nearest prime method and pass say 25. So answer should be 23, you know it. Now this is static. It prints output here itself. Nearest prime takes that number whose nearest is required. Okay. There's one more function which tells whether a number is prime or not. Okay. So you need these two functions on these two methods. It is right logic of first method. If n is less than 2, obviously it is not prime. Okay. Then you start with 2. How long you continuously checking? If it is less than or equal to half of n. You check once. If n is divisible by I, then n is not prime. Check with next number. Okay, this will continue till all the numbers up to half of n. Finally, you know what to do. Okay, and we are going to use this method in nearest prime method here for special cases. Special case 1. If n is equal to 1, then answer is 1. Sorry, 2. Nearest prime is 2 for 1. Okay. Next special case. If else, if n is 2. Okay. This time it is 3. Nearest prime is 3. Okay. Special cases are done. Now, else, if n is greater than or equal to 3. Okay. So you have I is below n, next is above n. Okay. Let us fulfill first below. Take I equal to 1. Enter into some infinite loop. Check if n minus I is prime. Break. Otherwise, take next I. Okay. Now, if n minus I is break, I is a distance from n to the prime on the left hand side. Now this is on the upper side. Take G. Repeat the same. While copy paste, you must be very careful. This is n plus j, checking on the upper side, and this is j plus plus. Okay, now if I is less than j, then the prime is n minus I, nearest prime. Okay. Okay. Here, nearest prime is n minus I, right? Else, if I equal to j, then both are nearest primes. Okay. What are they? N minus I and n minus I and n plus j. Okay. Here, else only one is left. What is that? Nearest prime is n plus j. Okay. That's all. So hope no mistakes. It is not IO, it is not IDE. It will not show red lines for mistakes. This is right line. Okay, for 25, nearest prime is 23. I'll take 27. Nearest is 29. I take special cases. 1. It is 2. One more special case. I take 2. This is 3. Okay. So hope you understand it. Let us take 100 as a number for the nearest prime 101. There are 2 primes. 97 is 1 prime, 101 is 1 prime. Now let us take 99. Then you get both. Both are closer. Okay. So I hope you understand it. I explained the logic as well. Thanks for watching and please subscribe. Thank you.